So we are group 9 and our project is authentication using brain signals. We have tried to model our app close to the Apple Face ID wherein you just look at it and you get logged in. So similarly over here, you basically ask it to start recording. It takes your brain signal and records it. Since we don't have any brain signal recording equipment, we are using the signals stored on our disk. So the moment you say start recording, it starts recording your own brain signals and in the meanwhile determines the network latency for the cloud server and the fog server. So since this happens in parallel, it does not take up any additional time in our app. So let's just see how it works. Start recording. In the background, it has decided to choose the fog server and it is collecting the brain signals in the meanwhile. Once the brain signal is here, we can select the login option and it sends the entire signal and authenticates on the server. As you can see some stats over here, the battery percentage was 39%. If the battery percent was less than 15%, the app does not bother to determine the speed between the cloud server and the fog server to save power and instead defaults to the fog server. You can also see there is a server round trip time and a remote server round trip time along with the server computation time and the remote server computation time. Together, the sum of these values determines which server to use. The smaller the sum of the network and the processing time, that server is selected. As you can see in the top portion, our server took 4.198 seconds to authenticate and the 0.91 seconds to transfer around. So around about for this scenario, the authentication took about 5 seconds. Now that we have seen the demo of our app, let's take a look at how do we use brain signals to authenticate a user. We have collected data from this website called PhysioNet, and it's the EEG and motor movement data from a research project. These are the set of tasks as you can see over here. Task 1 and task 2 are basically baseline tasks where we have to perform the same thing with eyes open and eyes closed. And then we perform 4 distinct tasks 3 times so that we have enough data for each user. For the sake of our project, we have used the data of a single user out of 109 available users. We use task 1, which is open and close the left or the right fist as our primary input. We use task 3 for training our model, and then we use another variant of the same task, which is task 7 for actual authentication purposes. Now, the algorithm that we employ is basically to extract features and then compare them. We have been provided 2 different algorithms from our impact lab that extract features and also compare the functions. So we extract features of our sample signal and the given database, and we compare those two the with each other so that we get the result. The comparison results this data against a build model and gives us a 1 or a 0 output. 1 meaning authenticated, 0 meaning declined. So one of the important parts of this project was an adaptive algorithm to determine between a fog server and a cloud server. A fog server is something that is located closer to the device and a cloud server is something which is remote. A fog server generally tends to be a low powered device as compared to a cloud server which is a server level machine. So there is a trade off between the network speed and the processing speed for both these servers. So let us start up our fog server on the desktop machine that we have over here. Use a Spring Boot service to do the authentication for us. So as you can see, the server has started. Similarly, let us start the same thing on our Impact Lab server, which is a powerful machine located remotely. Now that we have both the services started, we can use one of them to authenticate in real time based on the network statistics and the processing time for each server. So how do we decide whether to use a cloud server or a fog server? There are 2 important parts of the equation. One is the network transfer time and the other is the processing time. We ping a small file to each server to determine the overall network latency. However, we cannot do so for the data processing time. As a result, we have benchmarked both our servers, which is the fog and the cloud server, and stored some results so that we can directly use those. So here are some of the results for benchmarking our Fox server. As you can see, it takes approximately 5 seconds to compute a single result. Similarly, we have benchmarked the remote server, which takes 4 seconds. So evidently, the remote server is faster. To conclude, we have seen how our app works, the machine learning algorithm for authentication, the server setup for the fog and the cloud servers, and the adaptation algorithm to determine which one to use. Thank you.